All right, let's continue on. Nuclear radiation. Today, I will go back and review once again the importance of isotopes, and also I will explain what ionizing radiation does to living tissue. If we're going to continue to talk about radiation, we need to refresh our memories about something. What is an isotope? Who remembers? Jeffrey. Okay, so it's the same element, so it has to have the same protons, but different number of neutrons. The neutrons do not affect who it is, it just affects its flavor. It's basically different flavors of the same element. Different flavors of the same element. Yeah, those are isotopes of Coke. It's Coke, but it's different flavors. Samples of the same element with the same number of protons but different number of neutrons. So in this chapter, we're going to study radioisotopes. What are radioisotopes as opposed to just isotopes? Who did we use as an example here? Who was radioactive? Serenity. So Serenity would be the radioisotope. Somebody that at any moment could blow up and become somebody new. Okay? The rest of you guys are just isotopes or non-radioactive. When she does blow up, she could release alpha, beta, as Americans would call it, beta, if you're an English person, alpha, beta, or gamma, or some other combination of teeny tiny little particles. So, what happens if you're hit by a piece of something coming off of Serenity when she becomes something new? It could go straight through you. It's so tiny that it could go straight through your body. If it does, you're lucky. Congratulations. It could hit something critical in a cell and kill it. That's actually being kind of lucky. So if it kills your cell, you're not that bad off because your body can reproduce more cells. If you're getting to be really unlucky, it could change your DNA in some way. And instead of producing healthy skin, now it produces speckled skin. That's why as you grow older, your skin is going to get speckled. It is natural. It is due to the natural exposure of radiation throughout your life. So the longer you live, the more radiation you're exposed to, the more damaged your skin will become. You can accelerate the damage by spending time out in the sun, exposing yourself to ultraviolet radiation. So if you want to have more damage and more speckled skin, then by all means do not use sunscreen and go out there in the summer months and irradiate your body.
Did you get a tan?
No, that's still damage in your body.
Yeah, that's what I'm saying. Yeah.
Okay. It could damage the part, if you're really, really unlucky, it could damage the part of your DNA that's in charge of replicating. In which case, the cell could begin to divide and not know how to stop. A cell has a natural life cycle. It divides, and it does its thing for a while, then it begins to die, and then it divides again. If you change that life cycle, then what do you get? Cancer. Because the cell doesn't know how to stop dividing. So it is important to learn what kind of radiation we're being exposed to. We need to be able to detect when we're being exposed to ionizing radiation, because our bodies cannot do so until it's too late. If I was to give Randy this radioactive pen, and he was to hold it all day long, he wouldn't know the difference between a radioactive pen and a non-radioactive pen. His body cannot detect it. It's not until the nighttime when he looks in the mirror and he notices that swaths of his body and his left side of his leg where he had the pen in his pocket looks sunburned. That would be the first indication. If he received enough radiation, then the skin will start splitting open and bleeding. okay, then the chances of him getting cancer in those parts of his body will increase. But by then it's too late. So there has to be a way of determining that you are dealing with radioactive stuff before you die from it. And that is using a Geiger counter. Remember, it was designed by what scientist? Geiger. And what did he like doing late at night when nobody was watching? Counting things. Beakers. 2 beakers. 3 Erlenmeyer flasks. Describe how a Geiger counter works. When ionizing radiation enters the counter's tube or probe, it causes the gas that is stored there to become ions. Now that the gas has a positive charge, it can conduct electricity. When it does this, the counter registers a count. The units of measure are counts per minute, or CPM. All right. Got it? This is what a Geiger counter looks like. The one I'm going to bring will be similar to it. Here's a video from the English people.
Geiger or GM counters are one of a class of gas-filled radiation detectors that operate by using the ionizing nature of alpha, beta and gamma radiation. The GM tube is a sealed metal cylinder containing a low-pressure inert gas such as argon or neon. A thin metal wire runs down the centre of the tube, which is electrically insulated from the outer cylinder at the rear of the tube. The front of the tube is sealed with a radiation window that is specific to the typical radiation to be detected by the counter. For example, a thin mica window is used if the tube is to be sensitive to alpha particles and low-energy beta particles, both of which have low penetrating power. A thicker window, or a different material, such as glass or a thin sheet of metal, is used for high-energy beta particles, while for gamma rays the tube is often sealed without a window. The inner wire and the outer cylinder are maintained at a potential difference of about 1 kilovolt, and in the absence of radiation, no current can flow through the inert gas between the central anode and the outer cathode. The connections are made via wires into a connecting housing that fits over the rear of the tube. An outer tube guard will typically screw onto this to protect the actual GM tube. This tube guard can be open at the end or be covered by an end cap energy filter to change the energy and particle sensitivity of the device, or, if a carefully calibrated design is used, allow for ambient dose measurements rather than ambient count measurements to be made. The wires connect the tube to the control electronics, which supply power, perform the counting operations, and provide other functions such as conversion from counts to dose, data logging, data averaging, and driving the display. The tube works on the principle of gas amplification. Incoming radiation ionizes some of the inert detector gas, resulting in a free electron and a positively charged ion. The electric field inside the tube attracts the charged ion to the outer cathode, while the electron is attracted towards the central anode. The charge migration in the tube leads to a reduction in the potential of the anode and an increase in the potential of the cathode, either of which may be detected as a signal by the counter electronics.
Alright. So basically, a ray comes through, and any gas that it encounters, it converts into a negative particle, which is an electron, and a positive particle. The positive particle will be attracted to the ends. The negative particle will be attracted to the wire, and that causes it to move into the counter, and the counter goes beep. I'm bringing the stuff soon. It's in my house. Highly radioactive stuff with a Geiger counter and all sorts of fun, so that we can have fun next week.
Are we gonna die? We get cancer?
Yes.
Okay. You'll be the first one.
What kind of radiation can Geiger counters detect? Alpha, beta, and gamma radiation. Alpha, beta, and gamma radiation. What do you think background radiation is? What do you think background radiation is?
Radiation that doesn't affect you directly, but it affects you either way. Oh, no.
Wrong. It does affect you directly. What is background radiation? No, it has harmful effect. It'll eventually kill you. Yeah, the stuff that's naturally in the environment. You can't get away from it. You can't hide in a cave. Actually, a cave would have more background radiation in it. You cannot, it is the radiation you cannot hide from. It is the radiation you cannot avoid exposing yourself to. It is the constant quantity of natural radioactivity present in the environment. How do you factor it out when you're measuring radioactivity? Let's say that after giving him this bad, evil radioactive pen, I want to measure how radioactive Randy has become. Okay? What we're normally going to find is that he's not any more radioactive. You can't make Randy radioactive unless you give him particles that are radioactive. If you feed him particles that are radioactive. Having a radioactive pen does not make him radioactive unless some of the radioactive particles come off and it gets inside of his body.
Well, you become
okay, so what we're going to find is if natural radiation is 18 and we measure him to be 20, what does that mean? How radioactive is he?
Very radioactive.
2. Why?
Oh.
What do? If we measure him to be 20 counts per minute, and we know that the environment is 18 counts per minute, how radioactive is he? 2.
Is it always 18?
No, it's an average. It's an average. So to say that it's 18 always, so really what we would say if we got 20 is that you're not any more radioactive than the environment. Because sometimes if it's 18, sometimes it could be 28, sometimes it could be 10. Yeah. On average, it's 18. So what do? You factor out the background radiation from the counts per minute you get. You factor out the radiation from the counts per minute you get. What is a rad? What is another unit that means the same thing? A rad would measure how much radiation he was exposed to because of my radioactive pen. The gray is the SI official unit. So we're slowly phasing out rads in favor of gray. In favor of gray. How much damage that wonderful day that he experienced with my radioactive pen, how much damage he incurred would be measured in rems. Roentgen equivalent for man of radiation. REMS. REMS. R-E-M. That's what the musical group stood for, right? R-E-M. Roentgen equivalent for man. I don't think so. How is REM calculated? It's pretty complicated. You'll probably never ever have to deal with it unless you become a nuclear engineer or a nuclear technician. But basically they would multiply the radiation, how much radiation he was exposed to, times the type of radioactive particle. Alpha is going to be less, beta is going to be more, gamma is going to be more, neutrons is going to be more. So it's going to be calculated that way. Most of this has already been calculated, so all you have to do is look on a special book. What are the two factors that determine tissue damage? The density of ionization, the number of ionizations per area, and the dose, the quantity of the radiation received. So that's something that would have been calculated by a health physicist. That's what they're called, health physicists at ORNL and Y12, and then they would look to see how much radiation was coming off this pen, where he put it in his body, and because it's probably limited to his leg or maybe his chest, where he might have placed it near in a pocket, okay, that would all be taken into consideration. Why might a health physicist working for K25 have higher standards than what the EPA would allow for you guys? For you guys, the EPA allows 170. For a health physicist, they may allow 170 millirems. I'm sorry, millirems, thousands of a rem. For a health physicist like Asher, they may allow 1 to 20 rems. Why would they allow? Why would their levels for a health physicist be almost 20,000 times more?
They're exposed to it more, stronger.
It's their job. Did anyone force them to do it? No. When they go into the job, they know exactly what's going on. Just like Jackson may one day become an NFL player, if he doesn't know that it's going to take years off of his life, on the tail end of his life, then he's a fool. Playing football, playing baseball, all these sports, playing basketball, the amount of physical contact and physical exertion that you have to do. And Devon, same for you. You know that this is taking a toll on your body. It's not natural. But they're going to be paid very, very well. So yes, it is an unnatural use of their bodies, but they're paying for it. Just like these HPs are going to be paid for doing what they're doing. So their levels are going to be much higher than yours. What are some sources of background radiation? What are some natural radioactive sources? Give me some. What? Yes, the air. Every time you breathe, you probably breathe in 1 or 2 particles of radioactive that are radioactive. What else? The sun. Very good. And actually, closer to the sun you get, the more background radiation. So if you like flying a lot, you get more. Actually, airplane pilots and stewardesses, they have to raise their levels above 170 because they are exposed to cosmic radiation more often than people who just fly once or twice a year.
What if you're just so it would still affect you more if you're just inside a plane? Like, what if you travel?
Cosmic rays will go straight through the plane.
Oh.
Didn't you watch Fantastic Four? It went straight through the whole spacecraft, converting them into superheroes. Okay, and one supervillain. Okay, what about if you live in Denver? Do you expect to have your background radiation higher?
Yes.
Why?
Because mountains.
I mean, they call it the Mile High Stadium for a reason. You're closer to the sun. You're closer to space, so you get more cosmic radiation. Okay, what other source? Veronica is probably getting a higher dosage than we are. Why?
She's back there.
What?
She's back there.
She is back there. Why?
She's near the window.
No, it's not the window that should bother you. The cinder blocks back here are made of pulverized rocks. Those contain, the cinder blocks are going to contain more radioactive materials than the drywall. What else? You'll be consuming radioactive materials come noontime. Food. Bananas. Number one source of radioactive materials. Bananas are loaded with radioactivity.
They're also high in potassium.
Yes. Name some sources of human sources of background radiation. Every time they have tested an atomic bomb, it's blown bits and pieces, particles, dust into the upper atmosphere. All that stuff gets circulated by the air and comes raining upon us. Yes. Chernobyl, any kind of nuclear accident. Fukushima, they're concerned about how much radioactive materials are in the Pacific Ocean and washing up on shore in North America. What else? Any kind of nuclear power ships are going to release a smaller amount of radiation to the sailors that are involved there. But us living this close to RNL and Y12, Veronica, no, you're from here. Victoria is from Chattanooga. Veronica, so you're used to it. Yeah, we have a higher level of background radiation. How about just stuff from medical examinations? CAT scans, X-rays, any kind of medical exam that involves nuclear technology. Okay, so most of the exposure that you will have, you can't even do anything about it unless you stop breathing, in which case you won't care about being exposed anymore. That's the radon that's in the air. It's colorless, it's odorless, it doesn't react with anything, but it goes inside of you, it comes out, and if you're really unlucky, when it goes inside of you, it blows up like Serenity did and becomes something new. When it becomes something new, it's no longer a gas, so it stays in your lungs. So you have radioactive metals in your lungs that were deposited there when you breathed in radon gas and it exploded. Can't help it. The older you are, the more of this radioactive stuff you'll have in your lungs due to breathing. So think about that. The next time you take a deep breath, other natural sources, just being exposed back here to uranium, thorium, Veronica, so sorry. Next 9 weeks we'll move you up and we'll move someone else back there to be exposed. Medical x-rays, that's a nice little slice there. The more medical x-rays you get this year, the more exposure. Other types of nuclear medicine, consumer products, smoke detectors are highly radioactive. Okay, and then this teeny tiny little sliver right here would be nuclear fallout and nuclear reactors. So, I mean, can't really blame. Breathing is far more dangerous than being close to Y12. So, if you move away, you will move away from Y12, but you'll still breathe. If you're wondering what are the parts of your body, Emily, that are more radioactive, your neck region with your thyroids has iodine 131. Your lungs have radon, uranium, plutonium, krypton. Yum, yum, yum. Muscles, potassium and cesium. Liver, cobalt. Bones are going to have radium, strontium, phosphorus, and carbon that are all radioactive. Radioactive, radioactive. So I want you to go out singing that song, this time meaning it for sure, because you are radioactive, radioactive. Oh, you are radioactive, radioactive. The EPA says that on the average, you should get about 135 millirems. You don't start seeing evidence of damage until you get to 25 rems. Okay? So think about it that way. 25,000 millirems is when you're going to start seeing damage to your body. So you've got a ways to go. You're at 135. If you get some x-rays, you may get up to 200, 300, but 25,000 is when you're going to have some problems. What level of radiation is considered safe for the average person? 170. 170, totally normal. You should live a nice long life as long as you stay under 170. There's going to be some years in which you're going to be higher because you may have some health issues, but on the average, you want to stay under 170. What sources of radiation do you have a choice whether you expose yourself to or not?
The sun.
Good. The sun. You don't have to be out there unless it's your job. You don't have to be out there, and if it is your job, you could put sunscreen on. What else?
We'll look at 3 clues. UV radiation.
To a smaller extent.
Okay.
It depends on the clothes. What? Okay, you can choose whether somebody blows you up or not, I guess. How about medical x-rays? If you think you have a broken bone, you can say, no, please don't expose me to ionizing radiation. And you could just limp for the rest of your life. Most of us choose, please ionize me. Find out whether this is broken or not. Right? X-rays and other medical procedures. What happens if you're exposed to low levels of radiation? Only a small number of molecules will be affected. Your skin, your cells can probably repair itself. But what happens if you're exposed to high levels of radiation? At that point, a lot of damage you may have incurred. You may not be able to repair it. Chances of you dying increases. So what happens if your DNA and your cells are damaged? As we've already talked about it, it could kill the cell if you're lucky. If you're not lucky, it could change the way the proteins that are made, it could change the proteins that are made, and I think I misspelled proteins, that it normally doesn't make, or cause it to divide and not know how to stop. If that happens, you have what? Cancer. What are some diseases that are supposedly caused by radiation damage? Leukemia, which is when it starts producing white blood, your white blood cells don't know how to stop producing, and after they kill everything that's bad for you, they start killing you. So leukemia, you're literally eating yourself. Anemia is where you have not enough red blood cells. It kills your red blood cells. Heart-related problems and cloudiness in your cornea is cataracts. Yes?
Does everybody is potentially able to get cancer?
Yes.
Nobody's cancer.
Are we safe from low levels of radiation? We don't know. 170, chances are that over your lifetime you're going to get some form of cancer. People that are 95, there are very few 95-year-olds out there that have not battled some form of cancer in their life. And cancer, more often than not, is caused by some sort of radioactive material. How many millirens are we believed to receive a year from natural sources? Like I said, about 150. So dose, exposure time, area exposed, tissue type are all things that must come into consideration. Rapidly dividing cells are the most sensitive ones. Folks, your sex cells, yes, keep them safe. Your skin cells, anything that's rapidly dividing are the ones that are going to be the most susceptible. 0 to 25, you won't see anything. You might have some damage, but you won't see anything. 25 to 50, white blood cells go down. You suffer some resistance to infections. You're more likely to get infections. 50 to 100, you might start getting some ruptures in your skin and lesions. White blood cells go down. 100 to 200, you are in honest to goodness radiation sickness area. Nausea, vomiting, hair loss, blood cells die. 200 to 300, you start bleeding internally and you start dying. 300 to 500, 50% of you guys will die. And if you get over 700 rems, you're dead. These are people that would be very close to a nuclear explosion.
100%.